to be done with them?
Yes.
Science review. Are we ready?
Yes. Yes.
Sound waves move outward from their source in all directions. True or false? Jonathan, you had your hand up first.
True.
True. So if you remember that truck and the beeping its horn and the sound waves were all over the place. So they go all directions. Oh, close. So sound waves travel, this is still true false. Sound waves travel at the same speed through all kinds of matter. True or false, Christian?
False.
Correct. I was going to ask a question on top of that question, but then that will give the next another one away. Good job. All right, so name the three matters that the sound travels through. M.
Water.
That's one. What's the other one? This is not for candy. This is just this is to see. This goes back to the last unit. Water, liquid. Well, we can. That's four then. So water, liquid, gas. What's the fourth one? Solid. Very good. I'll give you candy. That wasn't one of my questions, but it's all right. No, she swatted it like a tennis ball.
Are you swatting?
Playing a game of tennis. All right, listen closely. Another true false. Sound waves spread out as they move farther away from the source. Olivia. True. So if you think about the sound wave, initially is closer and then it spreads like that rippling effect of the water. That is the best way to visualize. I'm a visual person. I like to visualize things. Oh, sorry, so if you envision you throwing a rock in the water, what happens to the ripples? Do they spread out and get spread out, or do they stay close together to the rock? They spread. Same way as sound waves. They spread as they move away from the source. Very good. A rapid back and forth movement is called an echo. True or false, Cole?
False.
A rapid back and forth movement is called an echo. Gabe?
True.
Yes. Oh, he caught it. Which state of matter does sound travel the fastest through? If you remember when I had those items and I had the hammer, what was the loudest? Helen?
Metal.
Which would be a what? A liquid, a gas, or a solid? Very good. That is correct. You're going to catch it. This is going to happen. Oh! It didn't happen. All right. What characteristic of sound depends on how much force is used to make an object vibrate? How much force? If something is given force, what characteristic of sound depends on how much force is used to make an object vibrate? Jonathan?
Volume.
Yes. Very good. So if you think of volume, if the volume is low versus if the volume is really loud, which one is going to require more force? The loud or the soft? Wensheen? Yes. So think of that with force. If you think of something that is causing an object to vibrate, which the vibration is what causes the what? Something has to vibrate in order to get a what, Tyson?
Sound.
Yes. Because the sound comes from the vibration, correct? That's what we hear, is the vibration. Not the sound wave, it's the vibration. Try to keep that in your mind as well. So what is the characteristic of sound that helps us differentiate voices? Owen, that was a fast hand. Quality. So does it have to be a voice that its quality can affect? What else can quality affect the way we hear it? Tyson.
You can tell a different kind of bird to another kind of bird.
Sure, you can hear a bird sound. What about a musical instrument? If a flute, a trombone, and a trumpet all played the same note, would they sound the same? No, that also has to do with quality. So quality is what we hear, is how we hear it. What characteristic depends on how fast the sound is vibrating? M. Yes, very good. The pitch. What is a pitch? If you are playing a musical instrument, or if you're singing, remember my tuning fork. That helps us find the pitch. Winsheen. Owen.
The higher the pitch, the louder it is.
Not necessarily louder. So it depends on how fast the vibrating. If it's a if it's a faster vibration, the pitch is higher. If it's a slower vibration, the pitch is lower. Okay? Sound is a form of energy or matter. Cole.
Yes.
No, what is it? Sound is it energy or is it matter? Cole.
Energy.
Yes. And we're going to be studying energy. Yes. I like that. Matter or energy? Yes. Do you like sugar? Yes. Sound is caused by a moving object that is reflecting or vibrating, and the answer is not yes. Reflecting or vibrating. Sound is caused by a moving object that is reflecting or vibrating. Ella. Winsheen. Yes. Remember, Ella, the vibration is what we hear. Okay? Reflection is sound bouncing off of something. Okay? So when we remember the picture of the canyon, the hard rocks, they reflect or bounce off the hard surfaces and they're absorbed into the soft. Large, hard, smooth, well, I just kind of gave you the answer. Large, hard, smooth surfaces absorb or reflect sound waves. Tyson.
Reflect.
What's that? I didn't hear you. I'm sorry, the mask. Did you say, so does it reflect or vibrate?
Yeah. First one.
Reflects?
Yeah.
Jack.
Vibrate.
No, so let me read it again. Large, hard, smooth surfaces. Large, hard, smooth surfaces absorb or reflect the sound waves. Tyson, you are correct.
Yeah.
I was looking at the next question, which I should do. Good job. Reflect. Remember, when I hit the hammer on the metal, did it sound loud or was it absorbed into the sound? Oh, because it was reflecting off of the hard. Now if I hit, remember I hit Santa with the hammer? Poor Santa. Was that loud or soft?
soft.
Because it absorbed the sound. Well, here we go. See, this is what I was looking at. Rough, soft, or uneven surfaces. Rough, soft, or uneven absorb or reflect. Emma.
Absorb?
Correct. I kind of gave that one away, didn't I?
Yeah.
Oh, close, but no cookie. So yes, I just got done talking about Santa or a pillow or something soft and squishy that's going to absorb. Remember the picture in your book showed the canyon and it showed the hotel room with all the soft pillows and cushions and curtains. Grant, please turn around and please stop. So the sound is going to reflect off the rocks because it's hard. It's going to absorb into the soft surfaces because they are soft and they absorb the sound. Well, we kind of talked about this one. Why do clarinets and flutes sound different even when they play the same notes? What is causing them? Ella, we kind of talked about this already. Yes, very good. Because a clarinet and a flute sound very different. But the quality is what makes them sound differently. But yet, oddly, when you hear them together in an orchestra, they work. Sound is an interesting thing. How can sounds make you, how can the sounds you make, if I can read, glorify God? What can you do with sound to glorify God? Gabe? Pray. But more than one answer here. Grayson?
Talk to other people in a kind way.
Beautiful. Love that. Owen?
Reading the Bible out loud.
When she? Helen?
Teaching other people listen.
You do that. Oh, back row. You get more candy. Christian?
Helping other people when they fall.
Well, that's not really having anything to do with sound. We're talking sound. That's a kind act, which is awesome. So we have, there's something that we're missing, which I could think of. We talked about Luke.
Reading the Bible.
We've already said that. Cole?
Playing music with like a guitar.
Yes, musical instruments. Very nice. Oh, catch. Oh, yeah.
Reciting Bible.
What's that?
Preaching a sermon.
Any others? Good answers. Boy. What's that? Jonathan. Encouraging. Christian.
Teaching other people about God.
All right. Elle.
Singing Christian songs.
And we've already said singing. I think we got it covered. Good job. Nice. We can do a lot of things with sound to glorify God. Very good. What can we do that's not glorifying of God that we could use sound for?
Oh.
Grayson.
Saying mean things to others.
Saying mean things to others. Oh, close. James.
Sin.
By using bad, like what?
Swear words.
There you go. Christian.
Telling people they look ugly.
That's not kind.
Wait, what?
Boy.
What do you say?
Owen. I'll come, if you think of it, come back. Huh?
Is encouraging.
Yeah. Very nice. Cole.
Singing bad songs about them.
You know a lot of bad songs. Luke.
Mine.
Oh, nice. Very good. Helen.
I forget.
Boy.
Saying shut up to them.
You know, that's I got it. Ella.
Using a musical instrument and making a super high unscreeching noise on purpose.
Yeah, that would do it. I don't know if God really cares, but I All right, let's keep going, friends. All right, good job. A sound wave that reflects clearly enough to be heard again is called. So if I am on top of a mountain and I say, Grayson, 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 what is the answer?
Echo.
Yes. All right, good job. What are 3 ways? So I'll do 3. The first 3. What are 3 ways that you can make an object vibrate? Ooh, gosh, everybody knows this one. Tyson,
Can I say, do I need to say one of them?
just one.
Pluck.
Jeff,
Blowing.
Sam,
Hitting.
those are our 3. Good job, friends.
I thought there was 4.
Well, there are, but I'm only asking for 3. What is the 4th one? Owen.
Rubbing.
Yes, very good. What are the 3 parts of the ear? Name one. Jonathan.
Outer ear.
Outer ear. Trying to give someone who. Luke.
Inner ear.
Inner ear.